Hello and welcome to the last unit of the semester, Planning for Inquiry. We're going to begin by doing a brief stop and reflect. What do you think are the most important aspects to consider as you plan your teaching? Take a few moments and answer that question when prompted. Now let's talk about the components of a lesson plan. The biggest question is, where the heck do I begin? And so some questions that you can ask yourself are, where are your students going? How are they going to get there? And how will you know when they've arrived? As for the specific components of a lesson plan, obviously you need your name, the general topic of your lesson, some sort of descriptive title explaining what the lesson is going to be about, a time frame explaining how long it should take to complete each of the steps or activities within your lesson, the grade level or levels that this lesson is geared towards. You have to have some sort of state standards that go along with what the students will be learning. It's also good, especially in the sciences, to include any common misconceptions that the students might have surrounding the topic of the lesson. You also will need student learning objectives. This is what students should be able to do once the lesson is finished. And the typical format you should be using is the student will be able to, followed by some sort of verb or adjective related to Bloom's taxonomy. You also should include any safety procedures students and teachers need to follow, especially if you're conducting any sort of lab activity. It's also important to include any adaptations and accommodations for students with IEPs and 504 plans, as well as ESL students. Vocabulary terms and their definitions are also important. When I say vocab terms, I'm not just talking about any general term. I'm talking about science terms specifically that will show up in the lesson, whether they be a direct term that they have to know, or maybe another science term that is used as a part of the lesson that they previously should have known, or they might not know the definition of yet. You should have a detailed description of each activity that's being conducted during the lesson, and you should be specifying what roles the teacher and students will play in their lesson. I like to add any guiding questions that the teacher is going to ask the students, as well as potentially some common answers that you might receive. Also, any supplies or materials that the teacher and students will need to complete the lesson in each of the different stages is helpful. And it's also important to have a completed and attached hyperlinked copy of any PowerPoint, video, handout, rubric, picture used during the lesson. That way, when you open that single document, everything is right there. So even though it might not be physically there, you can click that hyperlink and it will take you right to it instead of having to dig around in your files looking for it. So let's talk about scientific inquiry lesson goals. Goals are your general objectives, or they're going to represent the general purpose of a lesson, unit, or course. And to set goals, you need to keep in mind the following: guidelines of the scientific standards, students' prior knowledge, and students' interests. Now, there are three fundamental types of goals. These are what we call the domains of learning. You have the cognitive, the affective, and the psychomotor domain. The cognitive domain of learning refers to the mental processes involved in acquiring knowledge and understanding. It encompasses a range of intellectual skills and abilities as outlined in Bloom's taxonomy, which categorizes cognitive skills into 6 levels of complexity. And so let's briefly talk about those 6 levels. So the first one is knowledge or remembering. This is low stakes. Recall of facts and basic concepts. They're going to be defining terms, listing processes. This is pretty simple knowledge here. Number 2 is comprehension and understanding. This is where students are going to be grasping the meaning of information. So they're going to be explaining ideas, summarizing concepts, etc. Number 3, the third stage, is called application or applying. This is where you're using knowledge in new situations. You're applying information that you just learned and attributing that knowledge as a building block to a new concept or idea. So you're going to be solving problems, conducting experiments, etc. The fourth step is analyzing. You're going to be breaking information into parts to explore relationships between them. So comparing and contrasting, grouping information, or organizing data. The fifth level is called synthesis or evaluating. This is where you're going to be making judgments based on critical or criteria and standards. So you're going to be critiquing methodologies or assessing arguments. And then the last level is 6, and it's called creating. This is where you're going to be putting elements together to form a new whole. You're going to be designing experiments. You're going to be proposing theories. This cognitive domain emphasizes the importance of higher order thinking skills, encouraging students to engage deeply with content and develop critical thinking abilities essential for scientific inquiry and learning. In the lesson plan that you have to create for me, make sure you're trying to use as many different levels of Bloom's taxonomy as possible. We don't want all of our learning objectives to be at low level. We want a wide variety of learning objectives. The second domain is the affective domain of learning, and this helps learners understand their own values and how they develop over time. It starts with basic processes like listening and receiving information, and progresses to more complex processes like resolving issues and internalizing values. So let's talk about some of the different ways that this domain is used. So the first is receiving. Receiving involves a passive awareness of emotions and feelings, and a student must succeed at this level to learn at a later stage. Students listen and have a willingness to hear out others. That's extremely important. For example, a student at this stage waits to speak until someone else finishes speaking. So as teachers, we're not just teaching content, we're also teaching young humans how to interact with the world around them. So here's some examples of receiving. So a sample learning outcome would be listen to other students with respect. A sample assessment activity for this would be an audience member to another student's presentation and then write a summary. And the rationale for this is that through this assignment, students will learn how to listen effectively to others, as well as remember key details about their presentation used in writing the summary. So not only are they learning content, but they're also learning how to interact and listen to peers. The second, responding. A student actively engages in the learning process by receiving it and reacting to it. For example, a student participates in a class discussion of a book that they read. Instructional verbs include assist, discuss, read, and write. So let's look at an example. So our sample learning outcome, speak effectively in front of an audience and actively respond to others. The assessment or activity, present on a subject in front of the class and answer questions from peers about their presentation. You all do that when you do your micro-teaching session. And the rationale for this is that through this, learners will become more comfortable with public speaking, as well as more comfortable with contributing to a discussion in the form of answering questions. That's a skill that every human needs. Our third is valuing. A student values a concept when they express its worth or what it means to them. For example, a student may write an opinion article about a social topic that they feel strongly about, discussing and defending their stance. Instructional verbs here would include things like complete, explain, propose, and study. And so let's look at an example. The learning outcome, demonstrate and explain own values regarding various topics. Obviously, that's very broad, but depending on what they were specifically doing, then you can make it more specific. Now, an assessment or activity for this is write an opinion piece on an issue, explaining one's own stance and reasons supporting that stance. And so the rationale here is that through this, learners will explore not only their own values, but why they support their values, giving them a chance to understand more fully their own value system. That's an extremely important skill that more people need to learn. Number 4 is organizing. A student develops a value system by arranging their values or beliefs in order of priority. For example, a student trying to make honor roll realizes that they should prioritize studying for an upcoming test over going to the movies with their friends. Instructional verbs here would be things like arrange, complete, modify, and prepare. An example for student learning outcomes would be compare value systems and understand evidence behind those values. The assessment activity would be organize and compare different cultural value systems, evaluating the differences between them and why these differences may have arisen. And the rationale behind this way of thinking is that in doing this activity, learners will consider how value systems are put into place and organized, as well as the evidence that supports different value systems across the world, because there are so many different ways of thinking and viewpoints based on your prior experiences. And it might not be as noticeable in your classroom, but as your students start to have conversations and they start to learn about the other people in their room, they're going to realize that, well, maybe there's differences about this person that I didn't realize. Well, are those differences good or are they bad? Can we have two differences or think two different ways and still both be right, or would we both be wrong? Or is one right and one wrong? The next is characterizing. A student acts according to the values that they have developed and internalized as a personal philosophy. For example, a student accepts that cheating is unethical and completes a different assignment independently, even though a friend offers to let them copy their answers. Instructional verbs here would be things like display, perform, question, and solve. So, to give an example, the learning outcome would be to work well in a team of peers. Sample assessments, a group project, including group work on any assignment. And the rationale here is that by working in a group, learners must balance their own values with the values of the team, as well as prioritize tasks and practice teamwork. So we've gone over two of the three domains here, and it's extremely important that when we're creating lessons, that we not only look at the Bloom's taxonomy, the learning objectives that relate directly to their SOL standards, but we also look at standards and learning objectives that relate to peer-peer interactions and the different kind of ways in which students in your classroom are going to be interacting not only with you, but also with their peers, and including those in your student learning objectives. The last one is the psychomotor domain. This domain focuses on the physical skills, such as the development of hand-eye coordination and the use of motor skills. Psychomotor skills help people perform physical tasks in daily life and at work. And the areas of this domain will include the following. The first one is perception. Students use sensory cues to guide their motor activities. For example, a student may listen to a teacher's lesson and write down corresponding notes. Instructional verbs would be things like distinguish, identify, and select. Number two is set. Students feel ready to act upon challenges and resolve them. For example, a student who wants to improve their grade is motivated to study for their next test. Instructional verbs would be things like assume a position or demonstrate and show something. Number three is a guided response. Students begin learning complex skills, often through trial and error or by following instructions. For example, a student learns how to build a simple circuit by watching an instructional video. Instructional verbs here would be things like attempt, imitate, and try. Number four is mechanism. Students develop basic proficiency when performing particular tasks, often through practice. For example, a piano student feels confident playing a song assigned by their teacher after they've had weeks of practicing every day. Instructional verbs here would be things like perform or complete or duplicate. Number five, you have the complex overt response. Students learn to perform a task with advanced proficiency. For example, a piano student knows how to play a song without needing to look at the keys. Instructional verbs would include things like carrying out, operate, and perform. And number six would be adaptation. Students have developed their skills and can change them to meet specific requirements. For example, a culinary student knows how to adjust their recipe to meet particular dietary restrictions. Instructional verbs would be things like adapt, change, modify, and revise. Number 7 is origination. Students learn how to develop a new skill using principles learned while gaining the original skill. So, for example, a student who has taken ballet classes would be able to then choreograph a dance for a recital. Instructional verbs include create, design, and originate. So let's look at this, stop and reflect. What do you think about the following examples? What statement represents a broad goal or a general objective? And what statement represents a specific instructional objective? So, example 1, students will understand the relationship between the macro structure of chromosomes and the health of humans. Example 2, given a karyotype to examine from a person who has several chromosomal abnormalities, students will be able to identify one chromosome that indicates translocation has occurred and one that indicates deletion of genetic material has occurred. Take a moment and tell me which example 1 or example 2, would be a general objective and which one is a specific instructional objective. So let's distinguish now between the components that make up our instructional objectives. So within our student learning objectives, these are going to be derived from the SOL standards that you're targeting. They need to be extremely specific, and each objective should only target a single skill. It's too often or not, I have students submit lesson plans with student learning objectives, and the objective contains 3 or 4 skills, and they all just put it in one big learning objective. You should be breaking that big section apart to where each objective only does a specific skill. Action words used should range on the Bloom's taxonomy scale, and you should have at least 5 or more objectives for any lesson plan. Honestly, if you think about it, you could have 10, 15, 20, even for a simple lesson plan, because of all the different ways students can be learning. And so here are those categories and a list of different terms and verbs that you can use. Now, the components of a clearly stated instructional objective have 2 parts. You have a performance component and a condition component. The performance component will specify an observable student behavior, and the condition component will specify the conditions under which the learner is going to be assessed. Whereas a criterion component will specify the minimum level of acceptable performance. And so these 3 you can combine together theoretically into a single learning objective on a single skill, or you can individualize each of these 3 components into their own learning objectives. So let's look at an example. Here's our objective. Given a set of 3 liquids of different densities and lab equipment, students will be able to conduct an experiment to analyze the principles of density and accurately evaluate their observations in a lab report, achieving at least 80% on a rubric assessing clarity, accuracy, and depth of explanation. So this objective contains all 3 of those components. It outlines what the student will do, that's the performance, the resources that they're going to use, that's the condition, and the standard that they need to meet, that's the criteria. And so you need to do your best to include all 3 of those components in every learning objective that you provide. Here are some helpful tips. You want to avoid subjective phrases like really understand or appreciate. Those things aren't measurable. I have no way of determining with data if my students really understand something or if they appreciate something in the classroom. You need to consider how quickly students need to complete a task and how to measure how close the performance is to being correct. You also need to start with what you want to achieve and then work backwards. So if you know your end goal, you know the steps that you need to get to that end goal. So if you start just trying to get to an end goal that you don't know, it's hard telling where you're going to end up. But if you know this is where they need to go, then you can kind of track backwards and work backwards to get a very specific and detailed learning objective. You should repeat the process for each objective until you have enough to efficiently and effectively measure performance. So now that we've covered our student learning objectives and the different types of objectives that we could have in our lesson plans, it's time to talk about how we're going to assess our students to see if they actually live up to whatever learning objective we set in place for them. The two main purposes for assessments are to check children's progress toward a learning goal and evaluate what needs to be done to promote learning, and then also to create a snapshot or summary of children's progress at the end of a topic or over a period of time. And so we call those formative and summative assessments. Let's talk about formative first. Formative assessments, they're informal, they're opportunistic, without written records being made, and they're used to inform teaching and learning in all stages of a lesson. Now, the purpose of these formative assessments is to gather information about children's ideas and to use it to help create new and appropriate learning opportunities. It also provides tools to mediate assessment activities and to probe more deeply into children's thinking. Now, from the child's perspective, formative assessment can help them understand what learning is possible and how it can be achieved, as well as clarify what they may have done well and what they need to improve on or learn more about. Formative assessment is dialogic and requires children to communicate their ideas. So, for example, the teacher could ask things like, well, what do you think about that scenario? Or, why do you think that is the way it is? Or, what do you mean by that? Can you explain more about whatever that topic is? That way the teacher can get a better idea of what that student actually knows about the topic. These types of questions are going to stimulate discussion. They're going to help students articulate their current ideas. They're going to engage children by appealing to their personal memories and their willingness to contribute. It's going to ensure that all children are at least attempting, and it will generate a common knowledge. Once we as teachers understand what children already know, we can use that information to respond appropriately in our teaching. If all of our students know that 1 + 1 = 2, I don't need to spend 20 minutes teaching 1 + 1 = 2. I can move on to some sort of more advanced addition or subtraction, multiplication, or division. Now, in science classrooms, development is dependent on finding out and addressing the differences between a child's existing ideas and a more scientific point of view. It's important that teachers pick their questions carefully because some questions are more useful than others. Teachers may slip into asking questions to which children have to guess the right answer or attempt to find out what the teacher wants them to say by providing just random answers until the teacher tells them they're right. So let's look at an example of this together. So we're going to read through this classroom scenario, setting the scene. The teacher is starting a topic on growing plants with 5th grade students. Teacher: right. Now, what do seeds need to grow? Hands go up. Alice: sunlight and water. Sunlight and water. You think? What else? Bryce: earth. Compost. Put your hand up. You might be chosen to talk if you put your hand up. Come on, someone different. John: something to grow in? Yes, something to grow in, but what else to grow? Chloe says, blue pellets to keep away slugs. The teacher replies, but that's not vital. What else does it have to have? What other vital things? We've got sunlight, water, and soil. Dennis, can worms help them grow? My grandma has worms in her raised garden beds. Teacher dismissively says, worms? Dennis, yes, she let me dig them up and go fishing with them. Alice then chimes in and says, yes, in the soil. They make holes in the soil. And then the teacher replies with, yes, help the soil. Absolutely worms. Right. Now, I want you to put together a role play for me. So let's think about that scenario. And here are some takeaways from it. The teacher had not decided whether to stick to talking about germination. Seeds usually need water, air, and some warmth. Or to talk about plant growth. Plants usually need light, water, air, some warmth, and a growing medium like soil. So right off the bat, she didn't frame her question well enough to narrow the focus of her students to what she was looking for. She asks 6 teacher questions during this short dialogue and accepts students' answers, but doesn't sound too confident about them, like she's wanting them to give her a different answer instead of just validating, yes, that's good. Okay, so now we've got this. What other aspects? And maybe giving them some sort of hint to lead them to what she was actually wanting. Now, unfortunately, she doesn't prompt them, like I just said, and so they start just guessing random things like slugs, pellets, and worms. When she doesn't get the answer she wants, she quickly moves on to something else instead of helping bring their minds to the answer that she's looking for. This cannot happen to teachers who are asking genuine questions, which by their very nature will indicate a quest for information or understanding instead of just random guessing. Teachers do better when they take up answers positively and make it clear what they do not know or what is new to them, clarifying their role as part of the inquiry rather than the complete solution. The response we get from children depend on the types of questions we ask. From a question such as, what will happen to the plant if we stop watering it? The teacher may be expecting a factual answer like, it will die. In this example, the teacher is only interested in a specific answer. However, if we show the children an unhealthy looking plant and ask them what they think is wrong with it, we are more likely to hear a range of views and ideas. To engage children in learning conversations, we need to ask questions which show an interest in their experience or require them to express a point of view, giving their reasoning. The difference between the child's way of thinking and ways of thinking from a scientific perspective is defined as the learning needs of the children. The concept of learning needs helps us as teachers to target teaching strategies for different children, identify the next steps in learning, hold focus in discussions. So let's ponder another question. Is it always possible to plan for formative assessments? What formative assessment opportunities provide the sort of information that can be used to support planning? So take a few moments when prompted and answer that question. Let's move on to another type of assessment. Let's talk about self or peer assessment. Children can be involved with assessing their own progress, and to do so, they need to be clear about what they should be able to do as a result of their learning, which they could not do before. Just as children need to be taught to talk and think together in scientific ways, they need to be taught the assessment skills to monitor and manage their own learning. Examples of ways teachers can promote student self-assessments: you can use traffic light icons, thumbs down or thumbs up, draw smiley faces or other images. Whatever strategies are used, children need to learn to question and reflect on their own learning. Some types of questions students would be able to ask themselves: what needs to be done next? How can I best find an answer to that question? Is there any other way to find an answer to that problem? Are there any other words I could use to explain my views more clearly? Do I really understand the meaning of that word or just know that word? What reasons do I have for my belief? Why do I believe what I believe? Are there any other words I can use to explain my view more clearly? And the last type of assessment we're going to talk about is summative assessment. Summative assessments are a way to evaluate how much a student has learned in a science class and are typically given at the end of a course. They can help determine if a student is ready to progress to the next level or course. So examples of summative assessments could include things like conceptual projects that assess a student's understanding of a scientific concept in depth. For example, they can design and build an arcade game when learning about the different types of circuits. They could do presentations that require students to speak about what they've learned, which can indicate how well they understand the material. They can create a portfolio that focuses on the end result of a student's learning, such as a lab report, a final performance, or a series of photographs. They can have exams that are instructor-centered exams, or they could have state tests. Final projects, which are high-stakes summative assessments that evaluate how much a student learned during a time period. They also could have an essay, which is a summative assignment that evaluates how much a student has learned on a particular topic. Now, when we're assessing students, it's important that we give feedback and students know in advance what exactly they're going to be assessed on or graded on. And so one of the great ways that we can provide that information to students is through a rubric. Rubrics are guidelines for assessing students' work and describe students' performance at various levels of proficiency. They contain dimensions to be assessed, numerical scoring, and statements of behaviors, expectations, or assignment components. Now, the types of rubrics can be different. There's a couple different versions. You can have a holistic rubric. This addresses the entire performance as a whole. Or you can have analytical ones. This addresses performances divided into individual tasks or parts. You can also have, in your scoring rubrics, you could have different levels. So things like poor, this product was not completed or shows no evidence that the student comprehends the activity. Inadequate, the product does not satisfy many of the criteria, contains errors, and doesn't accomplish the given task. Fair, the product does not contain major errors or omit crucial information and does meet some of the criteria. Good, the product substantially or completely meets some of the criteria. Or outstanding, all criteria are met and the product exceeds expectations or includes additional outstanding features. So the way that you score students is completely up to you. It just all depends on what works best for whatever activity it is that you're giving them. And so here's what kind of a typical rubric might look like. There are tons of rubrics in this Canvas course because all of your lesson plans and micro-teaching sessions are going to have rubrics attached to them. And so why exactly do we need these rubrics? Describing the performance of students at various levels of proficiency is one of the main reasons. It also helps score students' work without any bias or inconsistency. Sometimes we inadvertently might show favoritism to a student over another and just give them a different grade, not even necessarily realizing that we're giving them a better grade or a worse grade just because of who they are. And so with a rubric, it standardizes everything. It also enables students to compare and discuss their self-assessment with the teacher's assessments. So you can give them certain scores and then they can look and go, well, I was extremely proficient or outstanding here, but there was another scenario that I was inadequate on. What could I have done differently there to maybe get a good or outstanding credential for that? The next thing is, whom are you planning to teach? Language skills. How will you teach students who have recently arrived in the U.S. and barely speak English? You might think that that is something you're not going to run into, but without going into too much detail, we had a student at the high school show up last week who got on a plane from his home country and landed in America, speaks very little English, and is now taking high school level courses in English. And so that's something you've got to be prepared for in the event that it happens. So you need to be able to alter your instruction for students who have been in the American school system for many years, yet are unable to read or write a coherent paragraph. So not only are you going to get students that are fresh off the boat or the plane, but you're also going to have students who, due to either some sort of disability or just inability, will be unable to do basic skills that are needed for coursework. The other thing is classroom behavior. What behavioral problems should you be anticipating? And how would you react when those behavioral problems arise? How would you help students take responsibility for their own learning? How can you get them invested so they feel valued and that they want to learn? You can have physical and learning challenges. How will you modify your teaching plans for students who have difficulty seeing the board or projection screens? How will you accommodate students with hearing problems? Can a dyslexic or attention deficit student be successful in your class? These are all different things that you should be thinking about when you're creating your lesson plans. Gifted students. What will you do with these students who already know what your other students don't? How are you going to keep them interested and allow them to think critically instead of just do more work? So let's talk about how we can meet the needs of this broad swath of learners that we're going to have in our classrooms. The first is differentiated instruction. A differentiated classroom offers a variety of learning options designed to tap into different readiness levels, interests, and learning profiles. In a differentiated class, the teacher uses a variety of ways for students to explore curriculum content. A variety of sense-making activities or processes through which students can come to understand and own information and ideas. You should be asking yourself, what other parts of the curriculum can be naturally integrated with the specific content of your unit or lesson? Especially if you're teaching science at the primary age level. The majority of the focus is not going to be on science in your classroom. It's going to be on math and reading and language arts. And so you've got to find creative ways at times to integrate your science and history curriculum into your math and language arts content. That way you can kill two birds with one stone, or be able to incorporate two different subject matters at the same time. You also should be creating a learning community. Cooperative group work will foster a sense of community and include all students. As students work in groups, they may volunteer or they may be assigned roles, such as the leader, who keeps the group focused on the task, the recorder, the person who records the discussions, the findings, etc., and the facilitator, who helps to resolve conflicts that may arise. As students work in groups, they may volunteer or may be assigned roles additionally, such as graphic designer, responsible for art or design of a project, and then the presenters, the ones that share the group findings with the class. So you can group a wide variety of students who each have their own unique strengths together and give them an activity to do and assign them the roles that they're best suited to. And so this week you have one assignment for homework 10, and for this assignment you're going to read Planning and Assessing Children's Science Learning and include summaries of the following concepts or ideas in your one-page single-spaced Arial 11-point font discussion. And the specific topic questions are provided in your Canvas assignment.